So chemistry 11.3, off we go. Number 1 is a guy named Boyle's law. And then the fill in the blank word is inversely. Inversely is a math word that means if one thing goes up, the other thing goes down. So if pressure goes up, volume goes down. Pressure goes down, volume goes up. It's just the way that the gases are going to go. Tomorrow we'll have an equation for that makes the quiz. Do a math bit, 2 problems behind me in just a second. Then everything else is basically just a run back. So whether you're grading an 11.2 quiz or an 11.3 quiz, or whether you were here or absent or what, it's all about the same. So the 5 characteristics of gases are: 1, expansion. Follow-up point is the word fill. It fills all of the space in which it's placed. Indefinite shape and volume. If you only said 1 of shape or volume, you got a half, but it has indefinite shape and volume. And then the explanation follow-up on that has the word fit. Fits any vessel. Compressibility is the 3rd category. That's based on a follow-up point that a large volume can fit in a pressurized tank. Low density. Follow-up point is that gases are measured with grams per liter, whereas solids and liquids are grams per milliliter. And then the 5th point is mixing, and someday there's a bonus point for the test, but it's not yet. 3 things for the kinetic theory: heat and motion are related. 2nd is that the particles of all matter are in motion to some degree. The 3rd is that heat is an indication of that motion. In other words, motion causes heat to be noticed. The 5 assumptions are: gas is composed of molecules, there's no attractive forces, of molecules, there's constant rapid motion, of molecules. If you're grading an old quiz, we were taking off a half-point maximum for forgetting the of molecules on that trio. Today I'd go maximum of 1 point, but tomorrow we could miss 1.5 points for the of molecules 3 times. 4th thing here is perfectly elastic collisions. 5th point is average kinetic energy is proportional to Kelvin temperature. And then our follow-up explanations on the elastic collisions point, we'd say no kinetic energy lost. The other follow-up was the gas composed, gas made up of molecules, first one, and that's most volume is empty space for gases. 22 is ideal gases. The other gases are real gases. The 2 circumstances are low temperature and high pressure. And then our quizzes have a little bit of variation depending on old or new. They both have the question, what is pressure? It's just a question of whether you're looking at number 1 or number 26. That's force per unit area. The new quiz today has, for what causes pressure, collisions of molecules. 28 has a barometer, or yesterday number 2 was a barometer. And then we have standard atmospheric pressure up to 8 ways. We're given 6 of them. Someday on the test that'll be bonus points, but yesterday we did 2, today we're doing 6. The test I'll give you up to 8 points on a 6-point question. So options: 1, ATM for atmosphere, 760 torr, 760 also for mmHg, millimeters mercury, 76 centimeters mercury, 14.7 psi for pounds per square inch, 1.013 times 10 to the 5th pascals, or if you want, 29.9 inches mercury will always work, 1013 MBAR for millibars would always work. Choose 2 or 6 depending on your quiz. Then new quizzes, the 2 things that cause decreases in pressure: 1 is altitude, so if you go to Denver, there's less air pressure there. The other is moisture, so if you go outside in the middle of a rainstorm, there's not going to be as much atmospheric pressure in the middle of our April weather in Pennsylvania. Hand over there?
Yeah, what was the last one you said for the pressure?
I don't know, I just kind of randomly set them.
It had to do with bars.
1013, 1013 MBAR, millibars. Yep. Anybody else is scoring kind of an issue off of what's this doing? Let's go back to owners to preview next quiz. 11.4 is going to have another guy with another law. And that's going to total 5 points from reading in 11.4 for new person, new law, new stuff. Then compared to today, everything from 3 down looks to stay the same to me. Today, that's true. Today's 1 and 2 stays the same. And then I have one new question, which is to give an equation for that law. So here's the equation for that law, where P stands for pressure and V stands for volume. So we'll take a beginning pressure times a beginning volume, multiply them. That has to equal a later pressure times a later volume, multiplying them. They'll give you 3 of those. We'll have to use algebra to solve and get the 4th. But we'll do math on that in just a second. But again, 11.4, 5 new points of reading from the new law. The quiz is basically a duplication. The only add-in is the equation that's really behind me. So total of 42, because 36 plus the 5 new plus the 1 behind me, that's how we got to 42. Question about those? Math examples, if you want to join me on page 282, that's where I am. How do you know a pressure when you see it from a paragraph? How would you know a pressure if you saw one?
You would have like a unit,
Yeah, like what?
like PSI,
How many options might there be?
8.
8. Okay, so pressure is from the quiz. Could be any of 8 things. To do these problems right, you have to make sure both of the pressures are measured with same unit. You can't have a PSI and a centimeter mercury in the same question. So we want the pressures to be a match of the same type. Volumes, how do you know volumes when you see them? Liters is fine, milliliters is fine. It's another volume measurement. Grams would be a mass. Other than liters, milliliters, anything in the liters family, there's another volume potentially they could do.
Like quarts.
Yeah, they won't go English system, but yeah, that could work in a different setting. But there's something that our book does do sometimes. Like cubic whatevers, cubic meters, cubic centimeters, cubic this, cubic that. Anything that's cubic stuff. Again, to make this work, you just have to make sure that the 2 volumes are using the same unit. So as long as the units are consistent, we don't care what they are. If they're milliliters, they're both milliliters. If they're liters, they're both liters. Just make sure that they match. So 11.1, 282, page 282, example 11.1 says, volume of a gas is 17.4 liters. So we're going to plug that in for volume number 1. It says standard pressure. So hold off a second, because when they say standard pressure, why do I need to hold off a second? What's one number that might work there?
22.4.
No, standard pressure. 29.9 inches mercury. Maybe we should use that one, but maybe not. Why are we on hold?
So you don't know what they want.
We don't know what they want yet, so we need to hold off on that. But here we're going to use any of our 8 numbers, but we can't commit until we know which system they're using for this question. We read on, it says calculate the pressure in millimeters mercury. Now they made a commitment. If they commit to millimeters mercury, what's pressure 1?
760.
760. Then it says volume changed to 20.4. So I'm going to stick that in
V2.
for V2. But realistically, if you get something in the wrong slot, why doesn't it matter? Multiply, you can multiply in any order you want, and then X marks the spot for that. So you're always going to know 2, you're always going to know a third one with a variable, and then the algebra is always going to be the same. What would we do algebra-wise to get this figured out?
Multiply P1 and V1.
Multiply the 2 where you know them both, whether that's here or there, doesn't matter, but somewhere you're going to know 2 of them, multiply the 2 that you know, and then
Divide by the.
divide by the misfit. So multiply the 2 that are paired, and then divide by the other one, and you're gonna have it. And I'm hoping if you want to push some buttons to verify you can do that. This is 648. And then what was our pressure unit they committed to? Millimeters mercury. Yep. Multiply the two that you have them both on the same side of the equals. And after that shows up on your screen, divide by the other number. Something about that. So let me do one more and then we'll call it a day. It says a sample of gas occupies a volume of 73.5 milliliters. So 73.5,
Volume 1.
that's volume 1. It is at a pressure of 710 torr. So the 73.5 has its given pressure, 710 torr. 30 degrees Celsius, what are you going to do about that? Nothing. It's a trick question. Ignore it. The only thing that matters there is that everything got measured at 30 degrees Celsius. The temperatures for today have to all be matching numbers, but that doesn't matter to us, as long as they match. If they don't match, you can't do it anyway, because you don't know how to deal with that until you read another section. They want to know what's going to be the volume in the future at standard pressure. So volume in the future, we don't know. Standard pressure, we know. We just have to pick the right number of the 8. They committed to who? Who was the system? Torr. So committed to torr? 760. And that's why I'm making you memorize like all 8 of those things. You don't know what they're going to do to you on any given problem. Question about the setup? So then again, the algebra scheme is first multiply the 2 that you know, and after you've done that, divide by the third one. And we're going to say 68.7. And what was the system for volume measurements here?
4 milliliters.
It was milliliters. Question about that? If you want a quick check, again, go back to the word inversely. Inversely means if one of them goes up, one goes down. If you had an exact amount, like this one exactly goes double, the other one would exactly go half. But if one goes up a little, well, all you know is the other one should go down a little. Or if one went up a lot, the other one down a lot. So if we want to do common sense quick check, from 17 to 20, that went up a little. So from 760 to 648, that went down a little. By percentage basis, they're equivalent, and then we feel maybe good about that. 710 went up a little bit to 760. So 73.5 went down a little bit to 68. Like it sort of feels okay, but that's not a super check, but it's decent. Question about what that is about. So homework that goes math off of this is to do some scattered letters, and then the main event is 8 to 11. So the letters are 1E, 1F. There's a 1G, there's a 2B, 2C, 2D. Syllabus has all that listed on it. It's probably easier to grab from that. But then 8 to 11 is the main thing. It should be 4 problems like this. If you're not math strong, there is no such thing as like easy math, I guess. But if you are pretty math strong, this is easier than the math we did in chapter 10 for sure. I do see 2 problems in the homework where they didn't give you consistent units. So there's 2 on the 8, 9, 10, 11. There's 2 of the problems that you're going to have to do a little bit of a unit conversion, because there's one that I see you get a liter and a milliliter in the same question. So you just convert one. Does it matter which one? No, but convert one. So there's a liter versus milliliter, convert one. There's another one that has torr and atmospheres in the same problem. So it doesn't matter which one you convert, but you're going to have to make those match with a quick unit conversion on 2 of the 4. So if 2 are like this, 2 of them you'll have to do a small conversion on one of the items before you can really use the law. Question anything about where life goes? 11.4 and the homework off 11.3?